Hello friends, this problem is related to calculation of design speed for a car that can move on a road that has some kind of friction. So problem is called the design speed of a car on a wet road. So it says when the road of a circular turn is dry, the maximum permissible speed for taking a turn on it is 10 meter per second. Find the maximum turning speed on wet road when the friction coefficient between road and tires reduces to half. So let us plan this problem first. How will you solve? So what is given? You have been given, that is, when road is dry, the maximum speed is 10 meter per second. That is given. So here we have this diagram shows the road situation. Let's say some point of time this vehicle is here. So this vehicle, when it's moving, basically has a tendency, so when it is moving in a circular path, it has a tendency to throw in the outward direction. So friction force on this vehicle will act opposite to the slipping direction, that is in this direction. So friction force will act in this direction. What other forces are acting? Other forces that will acting, so on this car, normal reaction and mg will be acting. Now how will you solve this problem then? You have to basically write equation of motion and then solve for the design speed and then consider the case of wet road. So let us take 1 minute of time and solve this problem. Okay, so you have solved this, so let us try to see it here. So I will solve this problem now. So what will happen? So the friction force, since this car is moving in a circular path, so friction force is equals to mb square by r. Let's say radius of this is r, so this is the mean radius on which this car is moving. So radius of this circular path is r and v is the designed speed, or let's say simply v. And what will be the friction force? Friction force is mu times n. So we can write friction force is equals to mu times n. This is equals to mv square by r, and n is nothing but equals to mg. So from here I can write mu mg is equals to mv square by r. So m cancels out, so we will have v square is equals to mu rg. So the designed speed in this case is root mu rg. So this is the designed speed for this track, and this depends upon friction coefficient, that is mu value, and this depends upon radius of circular track. Now this is for the dry case. So when the day is dry, let's say that day maximum permitted speed is v max, then we can say v max is equals to mu times rg and a square root of that. When the day is not dry, that is a wet day, friction coefficient question says it becomes half of the original situation. So let's say v wet day, this friction coefficient is equals to mu by 2 rg. So if you divide these two equations, you can say, or simply you can write 1 by root 2 mu rg, and the mu rg is what? Mu rg, a square root of mu rg is nothing but v max, so this will be v max. So we can write here v wet is equals to, this will be root 2 here, so 1 by root 2 times v max. And v max is given, that is 10 meter per second. So 1 by root 2 into 10, that is 5 root 2 meter per second. So on a wet day, the design speed or the maximum speed will only be 5 root 2, which is less than 10 meter per second. So you see, If the friction coefficient decreases, then designal speed also reduces. So we can say if mu value decreases, then design speed, this also decreases. Now question for you, how you can have the same design speed, that is you want to achieve 10 meters per second on a bad day. So what will you do to achieve the same design speed in case of a bad day? So I hope you like this video and answer this question in the comment box, and I will see you in the next video. Thank you.